LeetCode problem number 131, Palindrome Partitioning. So this problem gives us a string, and we have to partition it so that every substring of the partition is a palindrome. And we have to return all the possible palindrome partitioning of the string S. So what it means by that is, let's say this, for example. So we have to partition it so that all of this are palindromes, right? So using all of the characters inside of string S, this is the same, right? These are palindrome, this too is palindrome, and if the character itself is also considered a palindrome. Okay, pretty straightforward. So my solution to this is to use a recursive method, a backtracking method using recursion. So in the recursion, I have this 2D vector called the result, and I have a vector of string, which is this, that I call current. So current is what I will be using to push into result, and result is what I will be returning as the answer. So when the recursion is first called, let's say I have S is AAB, right, using the example here. So let's visualize how my recursion would execute. So my string is S, this will not change, but start will change. Okay, start at 0. And if start is equals to the size of S, in this case it's not. This is only when we reach the end of the string and we need to check. But since it's not, so we can skip this for now. Now here we have a for loop iterating through the string. I is equals to start, I equals to 0. And then here I straight away check. I have a function called isPalindrome. So this takes in a string, the left index and the right index, and basically just combines, basically just checks whether or not this string is a palindrome based on the left and right pointers. Okay, it's pretty straightforward. A basic for loop iterating through as long as left is lesser than right. Left will increment, right will decrement, and I'm just comparing if at any point they are not the same, that means they are not a palindrome, I'll return false, otherwise I'll return true, stating that the string is a palindrome. Okay, this function is pretty straightforward, but here I'm checking, giving it the string and the start index 0 and I is 0. That means what it means that it is checking whether or not this character is a palindrome. And since A in itself is a palindrome, right, because like I mentioned, a character itself, did you say here? No. But a character itself can be a palindrome because the left and right, which in this case are the same characters, are the same characters, right? Okay, so here I substring it, right? So starting position over here, and this is used to count how many characters I am substringing. So I minus start is 0, 0 minus 0 is still 0, plus 1 is 1. So I'm only taking one character. But let's say I were to be at 2, 0, 1, 2 at B, minus start is 0, then it will be 2 minus 0, 0, 1, 2 minus 0 is 2 plus 1 equals to 3. That means I'm taking 3 characters here from the start. This is an example of how substring works. Since A itself is a substring, let me put out my result and current. I'll be pushing back current, pushing back the string that I just substring into current. So current right now looks like this. This is A. I enter the recursion with I plus 1, which means start is now 0 plus 1. which is 1. I ignore this, and then I enter the for loop again. I is equals to 1. From here, I check whether or not this is a palindrome. Right, so I'm checking start and I. So I'm checking this character, which is the same character as before. So this will be executed. It will be a substring. We will push back another A. Enter another recursion. Start is equals to 2. I is equals to 2. Check palindrome. Yes, B is a palindrome. Substring it. Push back. Okay, enter another recursion. Start is 2 plus 1 is 3. And here, now that start is equals to size, right? 3, start is 3, and the size of S is 3 as well. So that means we have finished iterating through S. We have finished the recursion from this route. So what we do is we push back current into our result, like this. So, and then we exit, return, exit here. We come back from here, so we pop back. Once we pop back, I will increment to 3, and since it's 3, this for loop will end because I 3 is no longer lesser than S size, right? So this will return as well. Exiting this for loop, you'll come out from here, from this recursion, pop back, and now I will increment to 2, and now the starting is 1 over here, and I is now at 2. So we're now looking at string AB. When we check whether or not AB is a palindrome, it is not. So we do not do anything, but we increment to 3. Since we have reached 3, so what we do is we exit this for loop, When we exit, we return here. Our current will pop back. So now we are back to square 1. But the difference is I now plus to 1. So now our start is 0. Our I is 1. So now we're looking at AA. Since AA is a palindrome, we substring it, push back, and then recursion again. I start is equals to 1 plus 1, which is 2. So now we are checking, right? We haven't checked anything yet. So I is equals to 2 as well. So now we're looking at B as a character itself. And since a single character can be considered as a palindrome, so we substring it, push back, like so, and another recursion. Start is now equals to 2 plus 1 is 3. And then, since we have reached S size, which is 3 as well, we push back current into our result, and then return. So return here, pop back, and then increment I to 3. Once it's 3, exit this for loop, exit here, and then this will exit. We pop back again, pop back here, and now I will now move to I will now increment, to 0 to 2. So now we're looking at AAB as a palindrome. But since AAB is not a palindrome, this whole block does not get executed, and the for loop will just end after we increment I to 3. So once it ends, we exit here and we return the result, which you can see here, A, B, and then double A and a single B. which is the same as the answer provided in the example. Okay, so overall, this problem was pretty straightforward, and the answer hopefully was not too confusing. Nonetheless, that's all I have to show. Thanks.